Now, section 1.8 is where we start getting into the problem-solving math of chemistry. And this is not the worst math that we will do, but this is generally, and I mean this in the best way, the part where we lose the most people. So I really want to emphasize that if you run into trouble during this section, that you come and see me during office hours and that we make sure that we can get you through this. We will be using exactly this sort of mathematical problem solving that we're about to discuss throughout the entire semester and through most of the next semester, and in your physics classes and in all sorts of places, in your biology classes as well. This is a very common approach to scientific calculation, and I want to make sure that you understand this. So we'll work on this as long as we have to make sure that you have it. The main idea that we're going to be talking about is called unit analysis, and you can understand this idea a little bit just by looking at fractions. So if I have some fraction, whatever it might be, say 1/2. If I multiply something by that 1/2, I can do some canceling here. I can cancel this 4 down to 2 and this 2 down to 1, and I can come up with an answer. Okay? Just like if I have a slightly more complex fraction, this is multiplication here, I can cancel the same idea. Okay? So something that's on the top and bottom of a fraction, whether it's listed separately off to the left, or whether it's listed over the same numerator and denominator, we can cancel things as long as they're on the top and bottom of a fraction. The same thing works with units. So if I have feet, and I'm multiplying by inches per feet, whatever that happens to be, it's just like a fraction, like anything else. Feet are on the top and bottom of this fraction, and we'll cancel. So this is just exactly the same as if I put this all on the top of a fraction, and this on the bottom, and therefore things that are the same, just like the example where we had 3 times 2 over 3, 3's cancel, we get an answer. Here we have feet times inches over feet, feet cancel, we get an answer. You can even look at this algebraically, right? X times y over x and x cancel, you get y. Okay. So that's all that we're going to be doing here when we start talking about this idea of canceling units and setting things up so that the units cancel, this kind of factor analysis or unit analysis type method. Okay. Now, given that, we can come up with all sorts of these units of 1. So for instance, I know that there are 2.54 centimeters for every 1 inch. This is an actual identity here. This is a equivalency. These things really are the same. If I took out a ruler or a meter stick and measured this off, 1 inch and 2.54 centimeters are exactly the same. Which means that this particular fraction, 2.54 centimeters over 1 inch, is actually 1. Okay. Well, how can this be? Well, we can take a look at this 2.54 centimeters equals to 1 inch. This is an equation. Divide both sides by 1 inch. The 1 over 1 cancels. The inch over inch cancels. This is equal to 1. So 2.54 centimeters over 1 inch equals 1. Now, if something divided by something else is 1, the reciprocal of that is also true. I could have just divided both sides by 2.54 centimeters, and I would have gotten, is that a word? Hopefully. I would have gotten the same idea, except I would have had the inverse. So we can use these factors of 1 to convert from one set of units to another. So say I have a foot, 12 inches. I want to know how many centimeters that would be. So I can set that up by multiplying by this fraction, and that fraction equals 1, so I'm not really changing anything. You multiply something by 1, you're not changing it. But when I do this inches cancels with inches. The units I'm left with are centimeters. And when I punch this into my calculator, let's see, there goes 12 times 2.54. There we go, 30.48. And given that we had two significant digits at the beginning, we can say that this is about 30 centimeters. Now keep in mind that things that are exactly defined, like this 2.54 centimeters per inch, is an exact number and has an infinite number of significant figures. So what we did, and what we're going to see in our book, is we looked for a way to turn inches into centimeters, and we did this through this ratio of 1, which we refer to as a conversion factor. So whenever you work out these problems, like 12 inches equals how many centimeters, we want to do this in terms of this problem-solving strategy. And if you can do this, just do it. That's fine. You don't have to do anything in a particular way for me, but this is the first time you've seen this or you're not sure about it, kind of follow along and see where you go. But the idea is identify where you start, and that's typically a number that you're given that is not a ratio, such as 12 inches. You want to see, what is the end supposed to look like? Well, the end's supposed to look like, for this problem, centimeters. Okay? So in terms of the answer, I don't know what the number might be, but I know it's going to be in centimeters. So how do I get from here to there? Well, if I'm starting with inches, I'm going to need some sort of conversion. I want what I have to cancel out, so I'll put that at the bottom. I want what I want to get to end up as my answer, so I'll put that at the top of the fraction. And now I just need to know what numbers go in here. In this case, 2.54 to 1. Okay? So let's do this with a slightly more complicated version, say yards to centimeters. Well, where am I going to start? I'm only given one number, so it's got to be there. Where am I going to end? Some number of centimeters. How do I get from here to there? So yards. So I need to go, well, I don't know what yards to centimeters are, but I do know that I can go from yards to feet. I know that conversion. It's 3 feet for every yard. And then I know there's 12 inches to a foot. And hey, I know that 2.54 centimeter thing. So I can go there. So here's my strategy. Yards to feet to inches to centimeters. Okay? So given that, I can figure this out as long as I know the conversion factors that get from one place to another. And it doesn't matter if you knew the yards to centimeters in your head, wonderful, go for it. Or maybe you knew yards to meters. That's fine too. However you get from point A to point B doesn't matter, it's math. It's going to work out the same way anyway. So let's make this work. 1.76 yards times yards on the bottom, feet on the top. That's a 3-to-1 ratio. Okay, so 1.76 times 3. And so I get 5.28. Okay, so 5.28 feet. So 5.28 feet. Take it one more step. Times 12 inches for 1 foot. I know this is the way I want to run this fraction because now inches are on top, feet are on the bottom, just like yards canceled, feet will cancel here. And I get 63.36. Not rounding or anything really yet, just going to keep pushing this along. Inches. Okay, so then we take 63.36 inches times 2.54 centimeters for every 1 inch. And get 160.934, etc. centimeters, because inches canceled out. I'm left with centimeters. And now that we're done, we're in centimeters, so now we round. So we're going to round to the ones place here because we have 1, 2, 3 significant figures. So this is going to equal 161 centimeters. We're rounding up because of that 9. Okay, so let's do 2 more quick examples here. 195 pounds to kilograms. Try your strategy. Pause it. See what you get. Okay, so once we figured out our strategy, we'll make it happen here. 195 pounds, we're looking at 1 kilogram. The conversion I know is about 2.20 pounds for 1 kilogram. So 195 divided by 2.2 gives us about 88.6 kilograms. I put boxes around my final answer, and you should too when you work things out. Helps me to know, for partial credit purposes, where you feel like the stopping point is for your problem. Let's try this one. 6 foot 3 inches to meters. Pause it. Think about it. Okay, so 6 feet times 12 inches. That's going to give us 6 times 12, about 72 inches. We're going to add 3 more inches to that and get 75 inches. Okay, so we have about 2 significant figures for this inches. So 75 inches. Again, I don't know the direct feet to, or inches to meters conversion, but I know centimeters to meters, so that's part of my strategy here. 2.54 centimeters for every 1 inch. And I'm just going to keep going with this. I know I'm in centimeters at this point because inches have canceled out. So I'm just going to say that there's 1 meter for every 100 centimeters and see what I get. So 7 times 2.54, and then divide that answer by 100, and I get 1.905 meters, or to 2 significant digits, 1.9 meters. Now I can use density as a conversion factor just like anything else. If I have lead, something like that, it's about 20 grams for every cubic centimeter, not a problem. That's a conversion factor like anything else. I can use this in any particular way I want. Cancel whatever it is that lead. Okay, I have to include all the units here. Cancel out whatever it is I don't want to have anymore as units. Get the units that I do want, and away we go. So let's try that. See, so the density of jet fuel is about 0.768 grams per milliliter. This is a conversion factor. A mental note here, you're not going to start with that number. Starting with a ratio in a problem is where you don't want to be. Sometimes you have no choice, like you're converting from one ratio to another ratio, but if you have a choice, don't start with a ratio. So where I'm actually going to start here is the volume of jet fuel, which is 173,231 liters. I'm going to end with kilograms of jet fuel. So my plan, I'll go from liters. See, I can use milliliters here in grams, so I can get between those if I have that. So I better go to milliliters from the liters. So here to milliliters. Then I can use the density to go to grams, because I know milliliters to grams. And then from grams, I can go to kilograms because that's just a metric conversion. Aha! So there's my plant. I actually have it set up to do this on the next slide. Let's just do it here since we have all of our plans set up. 1 liters times, there's 1,000 milliliters for every 1 liter. Excellent. Now I'm in milliliters because liters have canceled. I have 0.768 grams of jet fuel for every 1 milliliter. Good. And I have 1 kilogram for every 1,000 grams. So milliliters have canceled, grams have canceled. My units are kilograms of jet fuel. So that means as long as I put the correct ratios in here, everything is set up the right way to cancel to give me the right answer. So 173231 times 1,000 times 0.768 divided by 1,000. I guess I could have kind of almost skipped a couple of steps here. Gives me 133041 kilograms. Well, this number is not exact. So even though we get 6 significant figures in the original volume, we only get 3 significant figures here for the density. So we're going to have to cut this to 3 digits. So we're going to have to go to scientific notation here. So 1, 2, 3, 4, 5. If you're not comfortable with scientific notation, by the way, definitely come and talk to me. We're assuming that you've seen this in high school, so you're familiar with scientific notation. But if you're not, just come ask about it. So our final answer to 3 significant digits, 1.33 times 10 to the 5th kilograms. So that's where we were going to originally do that, but I thought it made more sense on the previous slide.